Okay, welcome everyone. Let's get this started. This is Global Flood Crosscutting project that we actually initiated in 2021 by the Global Energy and Water Exchange, or GEWEX program, which is a core project of the World Climate Research Program. And we are part of GEWEX hydroclimatology panel crosscut project. A bit about the GEWEX crosscut project. Crosscutting science project at GEWEX allows the global hydrology panel, which is, if it is part of hydroclimate panel, it allows the global hydroclimatology panel to address scientific issues that are common to many regions in the world and allow the exchange of knowledge between regions and to synthesize the result at the global scale. So cross-cutting project involved the collaborative effort of many scientists across the board in order to achieve outcome that could not be achieved by an individual effort. So this initiative is part of GEWEX hydroclimatology panel, and we had our first workshop in 2022, where we brought many brilliant-minded people from across the board to share their knowledge. They funded project on flood-related research, and we provided a white paper to GEWEX about the outcome of the project. And then we started developing the proposal for this crosscut project, and we finished it sometimes at the end of last year, and we submitted early this year to GEWEX GHP panel for review, and the proposal is under review in GHP panel. So we started our monthly meeting with the folks interested in flood-related research, and this is our first monthly meeting, and we are hoping that you guys participate and support this initiative. And the meeting will be the first Friday of each month. So this month we are the first meeting. The first Friday is on March 7th, that where we are, and our next meeting in April would be on April 4th. And we a little bit about the structure of the meeting. A bit we provide information about global cross-cutting project while we are waiting for GHP to approve to review and a possibility approve the proposal. And then we have a guest lecturer, keynote speaker this session, because that was the first session. We couldn't arrange it, but from next meeting, we have our guest keynote speaker. We have Dr. Paul Bates from Bristol as our keynote speaker in the next meeting. And then we do have a team from Dr. Huan, who work on a case study of flooding, so that they would be able to provide some kind of update about the project and present their results. Juan, are you there?
Hi, Rita.
Yes, good. So yes, after I finish, then you're more than welcome to share your PowerPoint or whatever you have to present part of your case study research. And then at the end, after one presentation, we have discussion. And if you guys are interested to be involved more in this cross-cutting project, we would welcome you. And if you would like to share your research to the community and have presentation, we will welcome your presentation. We can put you in our list of keynote speakers. And I also share a Google document where we put all the information and data that would you need in order to research flood related issue across the world. So if you have any information about what type of data maybe in your area, in your region, for example, if you are working on flooding issue in China or India, any part of Asia or Africa, Europe or US, South America, would welcome your contribution. So if you know any kind of data that would help us in order to strengthen our initiative, you're more than welcome to add it to this Google Doc that I share in the chat. And also any modeling research, if you use any kind of modeling, if you develop any kind of modeling, we would welcome your contributions, and please add your thought to this Google document so that we can use this information while we develop the global crosscut report. Um, so um, let's get started with, because we do not have our keynote speaker for this session. We go ahead with Dr. Huan's presentation, and if you guys have any questions, please feel free um, to use Q&A or chat box to ask any question you may have about this initiative. Thank you. Juan, you're ready? Dr. Juan, you're ready?
Hi, Vida. Yeah, I'm ready, but I'm trying to share my screen.
Yes, you can
It looks
share it
like I have
now,
a
I think.
problem here.
Okay. Can you
I
try
try
it
to.
again? Because I gave you permission.
Okay, now let me do that again. I'm not
Mm.
sure if I should log in again to do this share. I cannot see anything. Oh, no. I'm gonna log out and log in and try that
Okay.
if that happens.
Yes. If some of you you're not familiar with what GEWEX, awesome work GEWEX is doing across the globe, and GEWEX GHP panel, I just put the GEWEX link in the chat. You guys can go through the website, learn more about the mission and the vision of GEWEX program, and also GEWEX GHP.
It seems I still cannot share my screen.
Okay. So can you email me quickly so that I can?
Sure. Yeah, okay, let me do that.
Yes.
Oops. Yeah, I just sent out.
Okay.
Hi everyone online. I'm very sorry. It's I cannot share my screen.
Yeah, hopefully I get it quickly and then.
Mm-hmm. Have you got it?
Not yet. Okay, so while we are waiting, Nima, I gave you co-host privilege. If you could help with people, want to.
Yeah, sure, Professor.
Thank you. So we are also looking at making kind of literature review for this crosscut project. So if you guys publish any research work, you are more than welcome to copy your citation here so that we could add it to the report. So there is a section in the Google Doc that I share with you all for literature review. So please go ahead and add your citation. If you done great work and awesome work in flooding, particularly from hydroclimate perspective as well as modeling perspective, we welcome your contribution as well as including your research work to the report. I got your PowerPoint, Juan. I'm going to quickly put it.
Okay, sounds great.
Yeah, so that you can.
Yeah, you worked last week, but I'm not sure
Yeah.
why today cannot work.
Okay, so I am going to share my screen and then can you guys see my screen?
Yeah, I can see it.
Okay, good. So let me slide show. Is it good? So let me know if you want me to go to the next slide. One.
Okay, it looks very good to me. Thank you very much, Rita.
Yes, go ahead, please.
Yeah, okay. Hi, everyone. I'm very glad to join this group and kind of take leading of this effort. We call it that a flood model intercomparison project. Simply, we call it FloodMap, and we just studied it. And today I'm going to just share a few of my initial thoughts. We are still at a very early stage to formulating ideas and questions, motivations, and goals, and looking for team workers. So if any one of you are interested, you are very welcome. And actually, I do see August, you are on the line, and I think you could be a perfect contributor. So I'm gonna start from here. Can you go ahead, next slide? So today I'm going to share some 3 points. The first, I'm going to give a quick overview of the existing flood-related MAP projects and working groups, and try to evaluate or kind of introduce where we are for this topic. And then I'm gonna introduce a little bit the sub-project, our motivation and the objective and the work plan. And the last, I kind of here, I'm calling out to collaborators. So next. With that, next, please. Yeah, the first one, MOPEX project. If you, I guess some of you must be very familiar of MOPEX, which was started almost 30 years ago by Professor Duan and Dr. Zhang Shaki, which is a very successful project, which focus on the hydrological model parameters and the parameter transferability among river basins. And the MOPEX has also very successfully established an extensive dataset, and which has been used for many years and even for today. So before that, the MOPEX actually was started kind of motivated by the very difference among the different land surface models. So which the MOPEX is very successful. Go ahead, please. Next, please. So kind of as the follow-on project of MOPEX, like PAP Decado and Penta-Array projects, which recently finished. So they're still built on the similar hydrological foundation and trying to reduce the uncertainty in hydrological modeling by improving parameter estimations, which involves more hydrological models as shown in the left. And then the PAP 10 years and the Penta-Array achieved successful results, also including improved parameterization and regionalization technologies and model benchmarking. And also, more importantly, MOPEX dataset was expanded to global scales, which are very important for the hydraulic modelers to rely on these achievements. And recently, the Penta-Array also we can see the growth in combining the hydraulic models with AI and machine learning technologies, which is also getting a very a hot topic. Next, please. Next.
Is it because I moved one? My laptop is just. Is it the next?
Okay, great. Just move. Yes. Should you move back the last one?
The last one. Okay. Is it the one?
Maybe okay. This is.
Yes.
Okay. So this is another project called the ISI MAP, which is more complicated MAP project, but not like MOPEX or the PARP narrowing on hydraulic modeling, but is MAP involves more sectoral sections, like including water, agriculture, and many others. But I put it here, it's not really very closely related to our project, but I put it here is because it's flooding is also one of the focus of this big project involving a lot of models. And the main progress and findings from this project also include they showed the strength of the example modeling, and they all calling out the model discrepancies are a big concern and challenge of this project. And yeah, go ahead, next one. And there are also other exact Marbex and PARB, etc. And there are some other groups, and you might also know that highly relevant to the modeling and into comparison, even though they're not having direct MIP projects, but they really do things very closely, very close to this kind of task. So the HyperX is one of them, and they involve a lot of models. Some of them are very familiar to might be very familiar to you, and all these kind of group and projects, the models involved are not demanded, but based on volunteering. So it's a wide open projects. So and over the years, like almost like 20 years since HyperX, they achieved some main progresses. They find that even though we have many models, but no one shows the best everywhere. So and the example forecast just combining different models and different impulse outperformance deterministic model, and they also demonstrate data assimilation can work sometimes, but not always, even though we know the advancement in the remote sensing is a big benefit for hydrologic model, but still there's challenges here. A lot of studies showing that combining the remote sensed soil moisture and with the stream flow can improve the data assimilation performances, but it's not, again, it's not always the case. And HyperX also shows the post-processing of the model results are very helpful, and uncertainty quantification is a critical part of that project. And HyperX also shows there's a big gap between the model development, even despite the advancement of the model, but there's a big gap between that and the operational. The readiness of the hydrological models is a big of the concern in terms of the real-time applications. So please go ahead. So there's another project called the Watch, studied almost more than 10 years ago by EU's sixth framework program. The main progress is again, they built up a very widely used data set, which could be very useful for our sub-project. So that's why I put it here. And it's also investigated multiple large-scale land surface models, but it's also one of the findings just confirm other projects that they found a bit disagreement of the runoff among the models. So please go ahead. And there's another group actually called the Global Flood Partnership, which is a collaboration framework between scientific sectors and the users part. I myself was heavily involved in this with GFP, which studied 2009, and I was involved at the very beginning. And the GFP mostly focused on global scale and regional scale, larger scale hydrologic modeling and monitoring and forecasting. They are really very focused on the ongoing flood events with operational models such as the GLOFAS, GFMS. GLOFAS is run by the ECWMF, and GFMS is an experimental platform by NASA. I was the developer back to the years ago. And there are a lot of models involved with GLP and also a lot of satellite flooding mapping products involved with GLP. And over the years, GLP got main progress and findings, including that they also, we can say that different model-based global flood monitoring systems showing the variable scales and satellite data can be useful to improve the flood modeling and monitoring. And even though next slide, please. As one of the next one. As one of the ideally major routine work by the GFB group is that for every ongoing major flood event, GFP and its contributors, participants would like put all their flood products together along the flood timeline. This shows you an example that putting together by my GFP colleague that once a major flood event happens and GLOVAS, they have middle range forecast and it brings in the product and the warning in, and then following up the GFMS, which based on the satellite driven hydrologic modeling and provide 3 to 5 days of forecast. And then we have the satellite radar-based or the optical bands-based monitoring products chiming and just align the whole flood lifetime. Over the years, we find that even though we have quite a few operational and routinely running products over there, but trace every major flood event actually is very challenging because this is the kind of the limitations of the capacity by the research sectors. We really need to bridge the gap and bridging the collaborators between the different sectors. And please next one. Next. Yeah. As for the GLP, one of the research-wise product, I would please go last. I would like bring up one of the recent publication. Last one. Go back, please. And back again. Can you go back? Yes, please. Thank you. I would like to point out the recent publication and a nice work done, very relevant to our sub-project, is that the intercomparison of hydraulic models, mostly our largest scale hydraulic model, led by Mark Trigg, my GFP colleague here. And this work, the main motivation is that we shows that even though there are different GF global flood models, but try to figure out their credibility at different regions. And we try to also want to seek how can we better use these different models together to output improve the flood prediction. So back to just this work has been done like a couple of years. And go next, please. So basically, the Matrick and his team selected about 6 models from the literature, and these models all have a good validation in different places across the globe, which provides a baseline for this intercomparison. And please go to the next slide. And the next slide can show you the tables, gives you details of the model's configurations and the model chain from large scale coarse resolution and downscaling to high resolution at 90-meter resolution. And this modeling configuration and the multi-model runs are set up for entire Africa. Please go to the next slide. It shows the go to next, please. Yeah, in the middle of the slide, the Africa, it shows the 90-meter inundation mapping from the 6 models, and the main conclusion. Last one. Go back, please.
Is it the correct one, or?
No, go back, and I go back to the Africa one.
Is it the one?
Go back. Yes, thank you.
Yes.
So the slides might be some automatic things there. Sorry. So the conclusion for this in the comparison is that we can clearly show that there's only like 30 or 40% agreement among the different models, even though they have been very well validated. So it shows there are a big challenge here ahead. So that's why we need to further step studying. So please go to the next one. I would summarize a little bit on the different MIP projects. Next one.
Okay. It is.
Yes. So yes, this one. Okay. Perfect. Yeah, this is a summarizing. Go back. Please go to the last one. Go back.
So is it this one, or so we have?
Please go back. Backward, back. Yes, this one. Yeah.
Okay.
This is next.
Okay, you want me to change it?
Yes, please next.
It's probably better if you provide the number of the slide.
Yes. This is the next one.
Yeah, go ahead. Next one.
Okay.
Yeah.
Is it? I don't see slide numbers. Okay.
Oh,
is it
yeah.
one?
Yeah, maybe you could just play it.
In the bottom left, there's a slide 14 of 32.
Yes.
One can give the number of the slide. It's easier for you to find when he's talking.
I cannot see the slide number
so
from my side, actually.
Yeah.
So I just go to the next.
Is it the one?
Now I can see it's slide 14. Please go to slide 15. Yes.
Oh, it is 15. Yes.
Yes. Thank you very much. So this gives you a very brief summarize of the limitations and challenges that we learn from different MIP projects. So the most common challenges here and the challenges here is that the model dependency or the model inconsistency. No model shows the best results everywhere. So behind of that, we the reason behind of that is that we are lacking the understanding of the uncertainty sources and their impacts of the model delineation of the various flood generation and evolution mechanisms across scales and hydroclimate zones. So and related to this, every existing projects that have done showed that they're lacking. They have the challenges in data availability and data quality, from stream flow to precipitation and other relevant observations like soil moisture and ET data, etc. And the critical baseline data set like precipitation and DEM things are very important for model calibration, parameterization, and regionalization. So these are all impacts the in the comparison to have us to really understand the difference among models. So this is the main point I want to make from this slide, to derive from those historical projects. And even though like CAPEX and GLP are still ongoing, but still we need to put efforts together to move that forward. So now I'd like to, starting from here, I'd like to introduce a motivation from this study. Please go to the next slide 16. Next one. Yes, so I think for this sub-project, the motivation lies in two gaps. The first one is understanding gaps. That's what I just said. The uncertainty among the hydrologic models, but also specifically we can address many of these details behind that. For example, like precipitation, error propagation across models, and calibration and regionalization, scale problems, etc. But these are all relevant to the intercomparison of the different models. So the other part, motivation lines the gaps we try to fill, is that the model advancement and the real-time applications, because we need to move to a next step to improve the readiness of these models to provide more timely flooding information. So this go ahead for the next one, slide 17. Slide 17, next one, please.
Yes, it is in slide.
Okay,
I
cool.
get it delay, but it is. Sorry.
Okay. Yeah, maybe. Yeah, I'm in China, so I'm in Hong Kong now. It's a long distance, and I put some science questions. All the questions in blue actually nicely put together by Vida, and I just put them here. And we can also ask many other questions here. I like to address like more modeling comparison related questions. There's still a lot of out there, but I just initially put some here. The first, for example, how do differences in runoff generation and routing manifest and evolve across time and space and within various models, and etc. I don't. And these kind of questions, we try to directly to understand the difference among the models, and with the goal to combine different models together in a in a more efficient way. So I would expect the output from this intercomparison project for better answering these questions and also moving the modeling results more practically useful. Please go next one, slide 18. So the objective would be two. Number one is to evaluate and comparing the simulations of long-term flood and short-range flood forecasting and improve the understanding of the mechanisms of the flooding at various scales and zones, and reduce uncertainty, and which are going to result in data-informed adaptive management strategies. So ideally, you would, for long-term goal, it will transfer to the Global South region. So that's the objective, and please go to the next one. I initially putting together some work plan. It's very initial, not finalized yet, because we haven't get really a team on this yet. So the first thing we're going to do the literature review and understanding the where we are and the problem, and just as I mentioned above, and we can still, I think there's still space, and maybe I missed something, and we can dig into there and formulate accurate science questions and the tasks. So then we need to collect the data and working out the different methodologies using model selections and calibration and validation. Actually, it's presented in the next slide, please. And after the, please, yes. And then we're gonna analyze the results and do the comparisons. So yeah, this kind of plan pretty much routine, but kind of the, I think that's the task that we have to do, and it might be involve different methods and different models from different perspectives. Yeah, please go ahead. Yeah, in terms of the model selections, this is just kind of under my top of my brain, and just the type some of the models, and we are now at the stage that still inviting contributors, and we still think about what kind of models we are really working at, like distributed models and lump models, and are these models are suitable or are good at the real-time applications, etc. We try to excuse me. We prefer, I myself prefer to have these models with this operational use as our preferred, because we are in terms regarding to our goal, we try to looking at like a short-term forecasting and this ongoing flood events. So those routinely runnable hydrologic models are usually have a better readiness for the datasets and model configurations, which can highly reduce the efforts, because all of this work are volunteered to do. So this is a challenge, a very big challenge actually. And before that, in the talking about the methodology, except the model selections, the data data part, we need to address the quality control of the critical data sets, particularly like a precipitation is a big part of this game. So we have to do a good study on the evaluate and formulate kind of our best estimation of the precipitation products for the modeling and calibration usage. Please go ahead. I talked to this. Please move forward. Next one. Yes, move forward one. I skip this. Yeah, this should be my last one, and I'm gonna. I think we are really just starting this project, and we haven't really moved very far for this part. We are calling contributors and also thinking of case study catchments. In my opinion, the case studies we have to this catchment has to have very good quality of data, precipitation, DM, etc. It's critically important. I would tentatively maybe we select catchments from United States and one from like China or somewhere, and definitely we're gonna put select at least one from Africa. In terms of contributors, I've reached out to some of the hydrological modelers, and I got very positive feedbacks, and concerns also raised by those potential contributors as case studies and how we're going to work together, how mostly like people tends to work on their existing projects, so that could reduce their efforts. But we have to make some more coordination to why we have to make sure this case catchment has to be could be a representative. It's not like just an individual. We can transfer this knowledge and to the other places. So these names I listed here, I've already reached out and someone already agreed to join us. And here I also calling out, send my invitations in this group and the audience. If I interested, please, if you are very welcome to join us, and any suggestions and what I left out in this presentation, please also let me know, and I would be very happy to discuss with you for the next steps and figuring out how from the data collection and the model setup, we can discuss more on that. So thank you very much for the time. I'm gonna stop here, and maybe we can discuss more online or offline.
Yes, thank you, Juan. Any question for Dr. Huan? We have a few minutes left.
Yeah, I have a question.
Yeah.
Yes.
No, so yeah, so there's a comment from Luis Fita that I'll also notice that you're referring to global flood models, but the flood is a result of other processes that are not necessarily included in the flood model, in the routing scheme. So you have the land surface model, physics, and the meteorological forces that also they're probably more relevant than the actual physics in the routing scheme. So when you're comparing those models, you're assuming all the different lane models and forcings, right? I mean, you're not providing, there's no common like runoff fields that all flood models are using. They all, each group is generating their own runoff fields independently. Is that right?
Yeah, that's good questions. Actually, ideally, I would think intercomparison for both runoff generation and runoff routing, both parts, and starting from the same input data from like same precipitation and DM, etc. But different model has their different structure and different parameters, which are hard to unify. But we can starting from the same precipitation, and every model, the model contributors can set up their own model and spin up their model by themselves, but we share the common input data set. And ideally, I would like to compare the model results and component by component and decomposition. You know, ideally, I'd like to make sure the model we can compare it at the not just the stream flow at the outlet, but also the internal stream flow within the catchment, but also like a soil moisture part and evaporation part. Those, at least those components which are on the water balance questions, you know.
Right.
So with that said, that we can make sure the model are we are getting the correct answer with the good input.
Mm-hmm.
So even though different model has a different structure and delineated by the different mathematical equations and parameters, but they can give the reliable results, which we can tell from the consistency between the calibration and the validation part. So we have more confidence of that kind of model give the good results.
Mm-hmm. Okay, so yeah, that brings to another question. So okay, so one we talk about floods, but you're looking at stream flow, so not flood extent. So that you're not evaluating the flood extent, you're evaluating its stream flow.
Yeah, I think this project we are more focused on the stream events, flooding events. But as you know, the stream extreme flow, they are not coming suddenly. They're still we need to consider the flooding event, the initial condition or the prerequisite condition before that event. So we still need to run the model long term and continuously to make sure the model has a good starting point.
Okay. Well, thanks.
Yeah.
One quick thing, we will have only 1 minute, guys. We have Dr. Paul Bates next month. Most likely he is going to cover the foundation part. That's what my understanding is with his work. So I do encourage you guys to attend that meeting because I'm sure he's going to provide some kind of deep discussion about the modeling part and the least flood model that he developed. So I let you guys have any question from Dr. Huan. Huan, can you put your email in the chat so that they can communicate with you offline if they have any questions about this work? And this is just we started, so we will welcome all your comment. And please put your comment on the Google Doc that I provided, your papers, your contact information, any kind of data you have, any kind of model you develop. So that would be excellent for this cross-cutting project. So we can integrate all this knowledge into the report. And I do appreciate everyone's participation. And since we are already at 10 o'clock Eastern time, I just want to wrap up this session and Thank you again for your participation, and we hope to see you next month in our meeting. And then my email address also is, I am putting in the chat in case you guys would like to participate in this initiative. We welcome you to this initiative. So thank you all, and I wish you a relaxing weekend. And we'll continue this effort next month with Dr. Paul Bates' presentation and also Dr. Huan presentations next month. Thank you again and have a great weekend.